Good morning. My name is Dr. Melanizer, and I would like to talk to you about motion and graphing today. Graphing is probably one of the easiest ways we can describe motion in terms of mathematics and physics, and I want to go over some of the basic concepts with you today. Our learning goals are to learn about motion and to learn about graphing in terms of motion. You'll need to do this to be able to see what motion looks like on a mathematical scale, and you'll be successful if you can describe motion in terms of speed and acceleration from just a graph. Before we get started, we need to talk about graphs. And this is a very simple graph. It has an x-axis and a y-axis. Now, usually in distance graphing, we have time as the x-axis progressing forward, and we have the y-axis, which is distance, starting at 0 and going all the way up to 24. When we look at the graph, every one of these points represents something. The further we move to the right, the more time has passed. The further up we go, the further away from our starting point we get. Now, I'd like to start with a very simple graph. This graph is flat. It starts at 7 meters of distance and ends at 7 meters of distance. What this means is the object is at rest, not moving, not changing position, 7 meters away from the starting position. It's a rock just laying there, or a student standing at the 7-yard line. An object at rest has a flat line. Now I'm going to change this slightly. I have the person at the 7-yard line take 1 step forward, and then they have gone 8 meters. The line is flat, they're at rest. Then at 5 seconds, they take a step forward, moving 1 meter per second, and then they stop again. And they rest at the 8-meter point. As they're going up, it's changing position. However, time is always passing here. Let's take another look. So here we have a person who's standing at rest, and then at the 4-second mark, they take a step forward. So they move from 5 meters to 6, and then they change their mind at 6 seconds and take a step back. The flat parts represent motion. The diagonal going from left to right represents going forward, and the diagonal going from right to left represents going backwards. This is a graph of a person moving forwards and backwards. This person is traveling at a constant speed. We know this is a constant speed because it's a straight line. And we can find how fast they're moving by finding a point on the graph where it lines up. And we can find those points where it lines up at 6 meters in 4 seconds, in 12 meters at 8 seconds, and 18 meters at 12 seconds. To find how fast you're going, just take the distance and divide by time. So 6 divided by 4 is 1.5. By the same token, 12 divided by 8 is 1.5, or 18 divided by 12 is 1.5. That means they're moving 1.5 meters every second. Now I'm going to show you a curved line. A curved line, when it curves up, means an object is speeding up. Its speed or velocity changes. This is what it means when you step on the gas. You are accelerating or increasing the speed of the car. In this case, it starts not moving much at all, then it speeds up faster, 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 until it reaches at 9 seconds a steady velocity and it stays at that rate. Now we have another one. This is also a curved line, but in this case, it's a convex curve. What this means is it slowing down. So we have the car moving at a steady rate, and then it's slowing down, slowing down, slowing down, slowing down, slowing down, slowing down, slowing down. And when it reaches a flat point, it has stopped. So if it's curved up, it's moving faster. If it's curved downwards, it's moving to a stop. Now let's take a moment to identify things. In our first graph, we have a line that moves up to the 18-point distance at 6 seconds, and then it goes back down. Take a moment, pause the video if you need to, and describe what's happening. All right. At the beginning, it's moving at a constant, steady speed. We know this because it's a flat line. At the 6-second mark, suddenly it reverses direction. We can tell it's reversing because the slope is going downwards. If it's moving upwards, that means it's going forward. Sloping downward means it goes back. So the person starts at the origin, they're moving forward, then at 6 seconds they stop, turn right back around and move the same speed backwards until they reach the origin again. That's what we can tell. Take a moment, look over the graph. Please be able to describe what happens at the 3-second mark, the 5-second mark, and after the 5-second mark. All right. Again, we start at the origin, and it goes forward at a steady velocity until we reach the 3-second mark. Then it stops for 2 seconds, and then it goes backwards, much slower. Moves at a steady rate, rather fast, stops and goes home much slower. Last one. Take a second, see what's going on. We start by seeing something that is slowly, it starts out fast, really fast, and slowly stopping for 2 seconds. And then it moves at a much slower rate forward. All right, if you have any questions, here are our email addresses. Thank you.